Okay, so this is part 2 of our systems notes where we were specifically solving by substitution. So we're going to take a look at the 2 word problems that were on your notes. Okay, so it says use a system of equations to answer each question. A 16-inch one-topping pizza at Palanza's is $17.85, and an additional $1.96 per topping. A 16-inch one-topping pizza at Monocle's is $18.80, and an additional 90 cents per topping. How many toppings would result in a 16-inch pizza costing the same amount at either place? What would the price be? So the first thing that we have to do is identify how many equations are we going to have, and that means like how many different situations do we have. So we have Palanza's, and we have Monocle's. Okay, and then we have to look at our information for Palanza's. Okay, so first of all, what is our input variable going to be? And then what is our output variable going to be? All right, so in the end, it asks us how much each pizza costs. Okay, so how many toppings? So we know that we're going to get out the cost. The cost is equal to something, right? For both of these. And so now we need to figure out what the cost is for each case, okay? So at Palanza's, you're going to pay $17.85, and you're going to pay that once. So that's the y-intercept, right? That's our starting cost. Our y-intercept is our starting point, our starting cost. Okay, and we're going to pay an additional $1.96 per topping. Okay, per means multiplication. So that's $1.96 per topping. I don't like using t as a variable because it looks like a plus sign, so I'm just going to go ahead and use x, right? So x is my number of toppings, and I'm going to let c equal my cost. Okay, for Monocle's, you pay $18.80 for a pizza, and then you pay 90 cents per topping. And the question is, how many toppings would result in a 16-inch pizza costing the same amount at either place? What would the price be? So now we have our 2 equations for each one, where our costs, which we're just going to go ahead and call C, is equal to these 2 functions, right? These 2 functions of toppings. And so what we want to do is we want the cost to be the same. So if they're going to be equal for each other, we can substitute this in for this C. Okay, so this is using our substitution. So now 90 cents times the number of toppings plus $18.80 is going to be equal to $1.96 x plus $17.85. And the variable we're solving for, because the only one that's left, is x right now. So let's see here. We'll go ahead and subtract our 90 cents. And we're going to be left with, what is that, $1.06 plus $17.85 equals $18.80. And so we're going to subtract $17.85 from both sides. And we get, what is that, 95 cents? Equals $1.06 per topping. So now we're going to take 95 cents divided by our 1.06. And we get 0.9, it rounds to 0.90. Okay, so what you have to remember is what x represents, and x represents the number of toppings. So I feel like I made an error here. Did I make a mistake? Because that doesn't seem right, but let's see here. Well, I'm not sure. Okay, so if you caught my error, let me know. You can leave a comment. Maybe I'll give you an extra credit point. But if x equals 0.9, then 9/10 of a topping gives you the same cost. So let's see what happens. If we plug in 9/10 of a topping, we should get the same cost, and then we'll know that I didn't make a mistake. Okay, so for Polanzas, when we plug in 9/10 of a topping, we get the cost is 196 times 0.9 plus 1785. And this is for Polanzas, right? And so 196 times 0.9 plus 17.85 is 1961. Okay, and so hopefully Monocle's is going to be about that too. Okay, so Monocle's is 0.90 times 0.9 plus 1880. And 0.9 times 0.9 plus 1880 is 1961. Yay! So if you could get 9/10 of a topping, which is about one topping, then you would pay $19.61 for each one of those. So make sure you write a complete sentence that answers both of those questions back at the top. Okay? All right, one more. Brunks and Teamworks have changed their pricing. You should probably pause and try this and then watch. Okay? Brunks and Teamworks have changed their pricing. To order class t-shirts for next year, Brunks is going to charge $9.65 per t-shirt and a setup fee of $43. Teamworks is charging $8.40 per t-shirt and a setup fee of $58. How many t-shirts would need to be sold for the companies to charge the same amount? What is that amount? Okay, so we've got Brunks and we have Teamworks, and we know that we are buying t-shirts, right? Oh, there's that T again. All right, I'm just gonna go for it. Okay, the number of t-shirts, and then we have the total cost again. Okay, so for both cases, we've got T is going to be t-shirts and C is going to be cost. So for Brunks, I'm going to move this over here. For Brunks, we know that you have a flat fee of $43 that you'll pay once, so that's a y-intercept. And then you're going to pay $9.65 per t-shirt. Okay, and that's going to get you your total cost. All right, for Teamworks, your total cost will be the $58 fee plus $8.40 per t-shirt. So again, both of these equations are set equal to C, so we can take this side of the equation and replace C with it. So we get 840 T plus 58 equals 9.65 T plus 43. And so we're going to subtract our 43. We get 840 T plus 15 equals 965 T. And we're going to subtract our 840 T. We get 15 equals 125 T. And when we divide 15 by 1 1/4, we get 12. So remember, T is 12 t-shirts. So if Brunks and Teamworks, if we ordered 12 t-shirts from Brunks and Teamworks, we should pay the same amount. So let's see what that amount is going to be. So we've got our cost for Brunks is equal to 965 times the number of t-shirts, and it's 12 for it to be the same cost plus 43. And so 965 times 12 plus 43 is 158.80. And hopefully we're going to get the same amount for Teamworks. So our total cost is equal to 840 times our number of t-shirts plus 58. So 840 times 12 plus 58 is equal to 158.80. And so our total cost for both places is $158. So again, make sure you write these in complete sentences, but the companies would charge the same amount at $158.80 when 12 t-shirts were bought. Okay. All right. Have a good day. Work hard on your homework. See you tomorrow. Bye.